Good afternoon, everyone, and here we are in the Boulby Mine, a kilometre underground, as part of MINAR, Mine Analog Research, where we're doing science and technology testing in the deep subsurface to prepare for the exploration of space. And we're really privileged to have Matthias Maurer here. Hi, Matthias. How's it going?
Hello. Excellent.
Good. And Matthias has been joining us this week, and we've been doing all sorts of sampling and looking at salt. So what do you think about it so far?
Brilliant so far. I mean, for me, it's the very first time that I've been in a mine, and I'm collecting already some of these samples, and I hope you can give me some more information on it.
Yeah.
I mean, I know we're in a salt mine, and the first questions I have to you is like, I have already some geological field training, but how do you distinguish, like, which type of salts you see here?
Yeah, so you've seen this one. I mean, you've seen quite a lot of this, right, around the mine. This is actually halite sodium chloride. It's actually identical to table salt. It's what you have on your table. But one of the things you'll notice, can you see all these sort of brown bits in here, black bits, different colorations? So this is salt that's 250 million years old, and it was formed in a giant inland sea that stretched from here to Poland. And as it was, can you imagine it sort of forming in this giant ocean, and it's dried out? Lots of mud and minerals were blown in, got trapped in it. And so it looks very sort of brown and black because it's full of all these different inclusions that were formed in the salt when it was laid down.
And the other two types?
Yeah, so you've got another couple there. So this you may have found, I think, just outside in the Mars yard, right? This is potash, which is potassium chloride. And you can see, I'm just going to show the viewers here. So there's our halite that I was just talking about. You can see that black-brown coloration. And this is the other one Matthias was just talking about that he picked up, which is potash. And it's got this sort of red-orange coloration. This is actually potassium chloride. Again, it's not pure. It's got other things in there as well. So you end up with these sort of black bits in there.
And there's even the third type here.
Yeah, and you can see what you've got there, which is quite sharp edges. You can see it's almost, if I hit that, I don't know, very difficult for people to hear that. You probably can't hear it, but actually what you're hearing here is something that sounds a little bit like a china plate. Yeah, it's sort of almost hollow ring to it.
Yes.
It's funny stuff. It's made of sulfates, so this isn't chloride, it's sulfates. And it's highly compressed, dissolves very, very slowly. So this is also another thing.
Okay, so why is the salt mine now a good place to look for life?
Yeah,
that's what I'm currently here for, training.
Exactly. So salts, generally anywhere where you've got salty environments, life can live in there, but not in all different types of salt. So, for example, this halite is fine, it's not toxic. As we know, we put it on our food, so you're familiar with places like the Red Sea where life can grow in there. But have you ever heard of the term water activity?
Not yet.
Okay, so that was quite important for you as an astronaut, what water activity is. Water activity is a sort of measure of water availability. So if you think about a water activity of 1, which is the upper end of water activity, that's pure water. Okay. And you've been drinking quite a lot of that right here. We all have to drink a lot of water deep down in the environment. Exactly, it's quite a dry environment. That's pure water, or near pure water. Water activity of 1. Something that's completely dry is a water activity of 0. This brine that you collected today, where did you get this?
Well, it was in the deep part of the mine. Like I went there, and thanks to you, I know how to collect the stuff in a sterile way without contaminating the interior part, because I understand that scientists here want to look if that could support life. Yeah,
so this is, as you say, this is a brine that you collected. You can see it there, sort of reddish colour, saturated sodium chloride, so sort of almost a slightly gloopy texture to it. This has a water activity of 0.75, right? So it's a lot lower than pure water. If you keep pushing that water activity down, you get down to about 0.6, and below that, life cannot exist. And a good example of a low water activity solution that you might be familiar with is household honey.
Yes.
Okay, so honey has a water activity of about 0.55. You open it up and put it on your kitchen table, and it never gets moldy. And one of the reasons for that is its water activity is too low for life. So you often, I guess you might have heard this phrase, as an astronaut in planetary sciences, generally, where there's water, there's life.
Yes.
If we find life if we find water elsewhere, if we find that.
I know there's life.
Yes. So that's what people think, but it's not true, right? Because you can have a water solution that's lower than the lowest water activity limit for life. So honey has water in it, and yet life cannot survive in there. So the real question of interest is what sort of brines can you have with a water activity that's too low for life? And some of these things like sulfates, magnesium chloride, calcium chloride can have water activity limits that are too low for life. So you can actually end up with a brine like this that you collected that looks like it's a nice watery solution for life, but in fact the water activity is too low. So whether a brine can support life critically depends upon the type of salt that's in there.
Okay, excellent. So, and me as an astronaut on Mars, would I look for different types of salts?
Yeah.
Or would I look for brine? Or what would be my strategy to help you solving the question if there's life or has ever been life on Mars?
Yeah, so I guess you as an astronaut, right, you want to know what sort of sample should I collect,
Yeah.
what would be the best sample to collect, and of course scientists sitting back here on Earth obviously want an astronaut to collect the right sample. So that's a really good point. So how do we do that? Well, first of all, like I just said, we want to collect the right sort of brine or salt because we want something that might be able to support life. If it's a type of salt where the water activity is too low for life, then that's not going to be very good. So how do we do that? Well, you've seen some instruments, haven't you, here this week? And I guess what have you seen so far?
Hopefully I will get the Raman that I can carry with me to identify, because I know already how to use that for distinguishing between these two salt types. I mean, what else?
I think that would be the ideal instrument. I mean, you've seen the Raman we have here that we've been testing. And a Raman is a type of spectrometer, which means you fire a laser at it, and depending upon the light that comes back, you can tell something about the minerals. And as you've seen from the Raman, you can look at halite or the sulfate, and you can tell the difference between these minerals. And the good news is that this technology is advancing so rapidly that many of these instruments have become handheld. So as an astronaut, you'll be able to walk across the surface of Mars, fire that instrument at particular salts, and you'll be able to say, that's sodium chloride, that's a sulfate, that's something else. And hopefully, once you've been trained up in looking for life in salts, you'll know, that salt's got a water activity that's too low for life, not such a good salt for the scientists, so I'll leave that one. This one's got a high water activity, could be a habitat for life. So that's the idea, that exactly as you say, you can take your Raman and maybe other instruments and look for life.
So let's assume I find this on Mars. Is there life everywhere in there, or is there a special location that you want me to sample to bring back? Or
this is a crucial point about looking for life, and you've sort of hit the nail on the head in terms of strategies for looking for life. Life is never evenly distributed through things, and I guess all of us are familiar with that, right? I mean, you walk out into a field, and you don't see everything evenly covered everywhere. There's more life here and there's less life there. It's the same at the small scale as well. So that bit of salt that you're holding, can you see the different inclusions in there? Some of black bits, we've got brown bits.
Like the dirty parts?
Yeah.
So I don't expect life in the clean parts?
Less in the clean parts. Microbes like the dirty parts because that's where organic food is. Other elements like iron, which they need as well. So you're absolutely right. You want to collect a sample that is sort of representative of possible microbial life in those salts. So you want to collect a big enough sample, there's a good chance of life somewhere in there. But you could use a Raman to look for organic signatures and select the bits that have places where there may be more chances for life.
So let's select this place here.
Exactly.
Do you think that's a good one? Show it to us.
What does everyone else think? Good one? Yeah. Maybe.
It's not the dirt below my fingernail. Right?
Yeah, so that's exactly right. And as the viewers can see, there's lots of little bits and pieces in there. And what Matthias is going to do is walk across Mars, and he's going to look at that, and he's going to think, look, there's some nice clear salt. But, microbes, life can't live on salt alone. So anything in there is going to be pretty deprived of food. But in these darker areas, we've got organic material, and we've got things like iron, which microbes need, magnesium, probably from minerals that got drifted across this ancient sea 250 million years ago and entrapped in the salt that could now provide food for life. So you can see that by learning about salts and the different types of things in there, you as an astronaut can learn what types of samples to collect and what sort of things you should try and bring back from an expedition on the surface of Mars.
Excellent. Thank you.
Thanks a lot, Matthias, and thanks for joining us this week. And hopefully we'll be doing more sampling as we continue with MINAR 5. Thanks, everyone, for joining us. Goodbye.